Please welcome Thomas Moser, Head of Data Science at Prewave, Stefan Fischereder, Product Manager for Industrial AI at KEBA, Takao Terano, Professor at Chiba University of Commerce, Michael Haslgrübler, Key Research and Area Manager at ProtoFuture. And this deep dive session will be accompanied by him. Your host is the Editor-in-Chief at Industriemagazin, Rudolf Loidl. Rudolf, now it's your turn. We're looking forward to an interesting discussion.
Thank you, Una, for your wonderful and, may I add, skillfully tech-enhanced introduction. In the next 45 minutes, I'd like to navigate us through the world of AI-driven manufacturing and supply chain management. We want to touch on the challenges we face and the potentials there are for future industrial use. We got an incredible lineup of panelists today, and only 45 minutes to go, so I would say let's dive right in. Let me start with you, Professor Terano. With 30 years of experience in AI research from the Tokyo Institute of Technology to your current position as professor at Chiba University, what are the key trends in AI-driven production systems in Japan, and how do they compare globally?
Yeah. Okay, my name is Takao. Thank you very much. It is my pleasure to come here. And I started my AI career about the beginning of 1980s. That time was the second AI era. They developed so-called expert system, expert knowledge directly into the computer codes. That time, strong traditional manufacturing companies, so for example, Toyota or Nippon Steel, such a big company developed so many expert systems. But almost all of them were failed because of the maintainability or expandability is very poor that time. Compared with that time, nowadays, systems developed based on so-called neural network or generative AI. So they depend on the data. So some of them are very successful, I think. This is the main trend in current AI. And interestingly, small companies with so-called industrial robots, they are not so intellectual, but they are used with human operators. This is the current characteristics of small-sized AI, I think. So, but that the interesting thing, robots are very friendly with Japanese. Because there are so many manga history, robots are not enemy, but friends of human. So they, human operators, believe such a thing. So collaboration with robots and humans is very natural for us. This is the second trend. And but the problem is that the knowledge transfer, or Professor Tao stated about Nonaka's organizational learning theories, Nonaka emphasized the importance of implicit knowledge transfer or knowledge transfer systems. So it is still remain a problem. How to transfer implicit or tacit knowledge into systems and maintain in long way. This is a very essential point, I think. That's all. Okay?
Thank you. Thomas, you're head of data science at Prewave. You and your company is using AI to manage supply chains. Could you briefly introduce yourself and tell us how Prewave is using data science and AI to tackle challenges in the logistics space?
Yeah, thank you very much for the invite. So my background is kind of in academia. I did my PhD and then started 7 years ago to come to Prewave and tackle the supply chain risks. And what we really do is trying to bring transparency to something like supply chains, which are inherently intransparent. And there's a lot of different challenges here you have to tackle. If you talk about a bigger customer of us, they potentially have 20, 30, 40,000 different suppliers. Even managing this and understanding where are the risks for my manufacturing production line is really hard. But in fact, you not only have to understand this, but you have to understand the deeper supply chain. And this is something which is really hard and in the past was barely done, which meant that a lot of decisions are made on best guesses, but not on data. And what we are trying to do is, or what we are doing, is increasing the transparency, giving data to people and to management, to our customers, so to enable them to actually make good decisions, to understand the risks in their supply chain, and to mitigate these problems. Yeah. So, yeah.
Can you share some real-world examples of your product?
Yeah, so there's various parts to it. For example, if you think about really drastic events like COVID outbreak, a war in the Ukraine, right? There are certain things people are not aware of. For example, in the Ukraine, it was the wire harnesses. So this was one product only produced there. And suddenly, I mean, everybody manufacturing knows if I miss one critical part of my component, nothing works anymore, right? So understanding what are the risks, for example, how I'm exposed to certain risks, to certain events, is one part of it. And this is data we understand by understanding the supply chains of our customers, understanding what is out there, where is the clusters of problems. So that's one way how AI can help. There is just a lot of information available. The problem nowadays is more, how can we aggregate this information to help people understand what decision they should make? And for this AI, and especially the advances we had in the last years, gives so much opportunity of solving this.
Mm-hmm. Yeah. Mm-hmm. Stefan, as the product manager for industrial AI at KEBA, can you give us a quick overview of your role at KEBA and how KEBA is leveraging AI to innovate in industrial automation?
Yeah, of course. Thank you for the invitation at first. I am a product manager for industrial AI, which can mean a lot of things. But in the actual factual thing that I do in my daily business, we created an edge accelerator device, which is used to mainly give our customers the calculating power on our control systems to really delve into calculating neural networks. So this is more or less the product I manage. And of course, in the last few years, the things around generative AI really exploded and overwhelmed everybody in the industry. So we're kind of looking to explore how we can utilize this as well, for example, in our engineering tools, and how we can really bring this technology to our customers.
Mm-hmm. Can you walk us through a typical use case that already exists?
So for the accelerator module, for example, machine vision is something that is really popular. So machine vision, we do this since, I think, forever in industry and manufacturing. But the thing that is new and enables us to do this really efficiently are neural networks. So for example, if you have to find objects inside a camera frame, this is very easily done with AI neural networks. So the neural networks, every one of you is probably familiar with that. And we bring our customers the capabilities inside the control system so that they can calculate such algorithms and really benefit from the technology inside the framework that our existing portfolio provides.
Mm-hmm, mm-hmm. Thank you. Michael, as key researcher at ProtoFuture, could you introduce yourself and your company and describe how your work is advancing the role of AI in smart production?
Yeah, so thank you. So ProtoFuture is a company founded for one thing only, namely transforming the industry. And we do that by basically cognifying the industry, by making it more sustainable, because this is what our planet needs, and by also tailoring AI to be human-centered. This is something which is really crucial. And my area focus on the perception field. So we look into how we can perceive environments, how we can perceive processes, how we can perceive what people do in these environments and with these processes, and to really focus on how to integrate this all into, let's say, a consolidated view, and to really, empower people to do better manufacturing. So basically things like predictive maintenance, quality control, avoiding resources loss, and we have a lot of projects in that area, a lot of different tools we use. And yeah,
can you elaborate on one particular project where your work has made manufacturing smarter?
Yeah, for example, we have a large project with a process company here in Austria, and there we really look into let's say the very insides of the process. So we are sitting down with the domain experts, we are applying the algorithms, we are analyzing the data, we are visualizing our solutions, we do discussions. So AI is not all about the technical things, it's also about engaging with the people and shaping a value out of that. And this is something which we do in a lot of our processes, projects.
Thank you, Michael. Before we address the potentials of machine learning and AI in the industry, I would first like to address the challenges. We're in Europe, after all, where we first see the problems. When we're talking about machine learning and AI in the production process, it's really not about basic research of AI models or so. It's about integration and the proper training of the models in the process. That's a question for the whole panel, so please feel free to interrupt if you need to. What are the biggest hurdles you guys face when integrating AI into existing processes or control systems?
Well, I think we can all agree on data quality is an issue, right?
Yes. Maybe I would add data quality on the one hand, but also domain expertise. So when we deal with the manufacturing industry, these are highly specialized industries. So basically they create money out of what they do. So they are highly optimized. So getting the knowledge, the domain knowledge out of the project part of the the machines, how they operate, of the individual people who are good at operating those machines. This is I think one of the major issues, and also data annotation is also a big challenge.
Let's stay at the first point that you made before we go to the data quality, which is a big issue. I think domain knowledge. How do you tackle that?
Rather simple, just by talking and by exchanging ideas and by sharing perspectives on on the things. So this is a thing which needs time, which needs trust. So it's a lot about applying human intelligence in order for us to apply artificial intelligence, and this is actually where we then make the impact, because we do our research, we survey the literature. This all has to be done anyway, but it's also very, very important, to find, let's say, the nail for the hammer.
You need domain knowledge, which means you need the engineer in the manufacturing plant. Do you encounter a high degree of collaboration there, or is there more of hesitation?
As usual, there is an initial hesitation which has to be overcome. But I think once a certain level of trust is really engaged or created, it's really easy to collaborate. So, if people perceive the other side, is also focusing on the problem and not so much on the tool, let's say, then it really goes forward, and then it's a back and forth. So every side benefits. And I think this is really important, that all the parties in the process can really benefit from the collaboration.
Yeah, we have some kind of issue with our kind of business we do with that. So basically, we are a control manufacturer, and building trust with one party is maybe proportionally building distrust with another. So basically, we have the experience that the companies, they don't want to share their inner workings of the machines with us, more or less. Because if we find something that makes their machine better, we could handily sell that to a competitor of theirs. And therefore, we are in a rather different situation because we're not as research heavy as your company is.
Yeah, I mean,
the trust building is the same, I guess, but I think there is some different maybe areas of how you can build up the trust.
Yeah, maybe we are a little bit easier to engage with because we are a non-profit research organization. So
exactly,
we have, let's say, maybe an easier start or let's say an upfront trust. But it's really important then to take the people on the road to really go down that road together and end up somewhere.
The first thing that came up was data quality. And the reality is, on the shop floor, maybe even in Japan, I don't know, that there is a lot of companies where critical machinery exists, where people don't even know what the software is that runs on it. How do you guys, that's an open question for everyone.
In Japanese industry, experts or human operators are very familiar with the continuous improvement of the target systems. They think the existing systems are incomplete. So they have in nature to improve them. So operators can change the system functionalities. But to export such Japanese systems, it is not good. They are not allowed in the exported manufacturing systems. Operators are not allowed to change the system functionality. So this is somewhat different. To overcome such issues, to assure data qualities, it is important. One thing is to generate new data, not to gather. It is one thing. The other thing is opposite way. We should make a system completely, fully automated ones. This is a somewhat different approach, but both is necessary, I think. Okay.
Creating new data to work on is I think, a very important point, because more often than not, the created data by the system is not really enough for algorithms to work properly. Other systems, I guess, there are a lot of sensor data available where you can really do all the things and do the analysis, but I have the same feeling that very many operating lines are not too well equipped on sensor data and really storing that somewhere in a particular way to work on that.
So many data is better, but importance is very small. Item is not so large. So this is a somewhat contradicting conditions.
Thomas,
maybe to breach the bridge between the trust and the data quality, because if you're not really able to say I really want to automate a factory and I cannot claim I can deal with all edge cases properly, I will not convince management to put something into place. And I've seen projects where it really failed on that from a data science perspective. You have something which can improve the system, but let's say the management didn't want to take the risk, because for them, if it goes well, it's a little bit better, but if it goes bad, it's a huge risk, right? So overcoming this kind of trust issue is also really a data quality question.
Yeah.
Michael?
I mean, yeah, I guess this fear of loss is also something which somehow is always, hindering us a little bit. So if you consider, what the Americans are doing, they are investing millions and millions and millions just on, for example, OpenAI. So just the amount of spending which is done there with no early revenue coming. This is kind of hindering us to a very large degree, and I think this is somehow where we need to change a little bit.
But isn't it
our attitude.
that it's hindering maybe the basic research? Does it really hinder industrial application of AI?
Yes, it does, because these things we talked about, ensuring data quality, ensuring trust, those take time. And time is money, so it always takes money as well. And I think this is, and it's not like you can go to a highly optimized industry, apply some algorithm there, and on the next day you have a money printing machine. This is not gonna happen. Okay, it takes really investment. It takes focused work of experts to arrive at a certain level, and this takes time. And we need to do these types of investments. We need to change the industry. We need to, stick to the goals we want to pursue. Okay, and head down that road. I mean, this is what we need to do. So, standing still will probably end up in us being still there.
Yeah. Also, I think it takes time and invest for companies to really build up their own counterparts of AI companies. So data science departments, and really build up some kind of knowledge inside the companies takes money and invest. And I think that's crucial for making these processes even faster, and really have some people inside your own company curate the data already, such that experts like the ProtoFuture can come in and start on earlier and faster. So.
Where does the Austrian industry stand there globally?
Difficult question. I think as of my experience, when I go to customers and tell them that we now have something that can calculate neural networks, more often than not, the purchasing department, that is the counterpart, is so. And what does AI exactly do now? So the knowledge built up in the industries, it's now getting better over the past 2 years, I think. So before the rise of ChatGPT and then the big hype around AI, nobody actually knew that AI existed, more or less. But now it's getting a little bit better. But I think we have some kind of work to do here in knowledge building. I don't know.
Yeah, maybe I think in terms of good ideas, we're really good. But very often these ideas somehow they go there, and then we don't see the investment yet, or the return on investment yet, and then they are turned down. And somehow we have this gap between investment and potential, where the Americans are much better at. So high gains, high risk, high investment.
Thomas, the question to you as well, because your clients are international, I would say, no? Do you see a comparatively high interest from Austrian companies in your logistics forecast service? Or
our clients are, of course, very international. It's bigger companies which have headquarters and like, let's say, facilities around the world. Of course, we have a lot in Germany, Austrian as a market, as clients. But more on a general note, I would say in industry, you have certain, especially in manufacturing, there are certain cycles you work on, time frames you work on. And what we see right now is that the research and the progress in AI is just incredible fast. And it's just very hard, I think, for all industries to keep up with this. If we say now investments, I could think of a million things where you could invest to apply AI to make things better. Selecting the right one is actually not so easy. Like where do does your money bring the most impact on your production line? So I think we are in this interesting situation where there is so much opportunity. And yes, you can put so much money on this and make so many things better. But it's also really challenging to work with this really quick update cycles, this really quick research in this kind of industries.
Mm-hmm. Final question on the obstacles, so to say. How do you guys see the EU's recent regulations on AI? Are they what effect do they have on specifically on the application of AI in the industry? Do they have an effect as Europe as an innovation hotspot for this, or don't they?
Well, I think for machine builders especially, it's quite good that they now have some kind of guidance. They know that there is some kind of regulations. I think machine building companies tend to have, they like Maschinenrichtlinie and things like that, because then they know exactly where they can go and where the limits are of something like that. For the innovation part, I think it could be kind of hindering. But
why?
I'm not a researcher, so.
Okay.
Okay. I think that the beginning of 21st century, only Google can learn from data. But these years, we can learn even in small computers. So this is advanced technology. And in my experience, recent AI machine learning techniques work well, even from the small data. And interestingly, some older version of large language models, say GPT-2 or such a thing, it is free. But using such systems, with small, our own data, they can learn. And the performance is very well. So in such a case, data are considered to be some sentences. So then we design new type of manufacturing systems, such as somewhat established techniques.
Could you tell us, are there similar ideas of regulation in Japan?
Yeah. Our regulation in Japan is very, very severe. And they are very conservative. So to develop advanced AI systems, it should be used to establish software or establish techniques.
So did I get that right? In Japan, there is a higher degree of regulation?
Yeah. Okay. So too severe, I think.
I think the interesting thing is, regulation can be both a burden, but also an opportunity. And if we think about it, so we have these high standards. So if we can build the technology to adhere to these standards, they fit the rest of the world. But the other way around, it's very difficult. And since we as European, we learn from these regulations from a very, very young age already. So we are
as we were told that the machinery industry likes the regulation?
Exactly, because basically then, especially with AI, there are boundary cases which you cannot really, which you know there are, but maybe you don't have enough data on it. So having let's say an outside box which somehow regulates your thing is actually kind of beneficial, because then you're on the safe side when you operate machines with AI, that they are somehow safe for humans to work with.
Exactly. I think it also builds some kind of trust that you have to operate inside these boundaries, and you cannot build something and sell something that does not adhere to these regulations. Right.
Do you think, only a quick answer, that there is no regulations or little regulations in the US because the technology comes from there? Or is this just another mindset there?
Mindset, I would say.
Yeah, I think mindset, yeah.
And also, we had just recently a talk by a law professor at JKU, and also the legal system is completely different. So here, the standard way is regulate first and then do something. And there it's, do something first and then regulation comes in. And this is what we already see now also with so we have the AI Act now, it's there, okay? So we can build on it. The US is starting to do that right now, because they see now, okay, this stuff has a lot of problems, we need to deal with it.
So everything is forbidden unless it's explicitly allowed in Europe, as we grow up with that.
Yeah.
Let's move on from the limitations to the potentials of AI in industry. That's a question for all of you, and I'd like to probably start with Michael. As AI advances, what untapped potential do you see in autonomous manufacturing systems?
One of the very nice things about these systems is basically you can define multiple objectives which it should pursue in its training algorithm. And I think this is really something where we are not completely there yet, but me and my team, we are working on this stuff, that we not only focus on being just more efficient, but also have secondary targets like avoiding a lot of waste, because you produce the thing faster, but it has also more waste. So you optimize it a little bit to be, let's say, less efficient, but then you avoid the waste, and then in overall, let's say, you have a better or it's economically and ecologically better product. And I think this is really the really nice thing about these things, about the AI models, that you can add these objectives, and it can you can balance those things out, and then you get something which is more than a single optimization system.
What untapped potential is there in logistics?
A lot, I would say. Working in the job of getting information out of public available sources or others, there's infinite amount of information, right? So understanding it is the challenge, and there are a lot of different kind of information which can help you in your supply chain and understanding risks. Just if you think about what kind of things can happen, from like a disruption to financial things to natural disasters and all of this. So I would say in the last 2 years, the technologies which came up, I cannot understate how quickly the changes are. Really, every month you kind of have to sit down and rethink things and get new models and tune them and so on. So really, these update cycles are a huge challenge we can do as a startup, but I imagine it being an impossible challenge for a lot of bigger companies. Yeah. So from the applications, I see limitless applications, and I'm looking forward to tap as many as possible in the future.
What potential do you see?
Well, as the shortage of skilled labor is increasingly present in the industries, in the manufacturing industry especially, I think that things that are really a lot of human labor right now can be automized even further with the use of AI. For example, if you take quality inspection at the end of line, that is mostly, or in a lot of production lines, it's still done by humans, and they take the thing and look at it and say, yeah, that's a good one. And really automizing these processes can enhance really the productivity and also a little bit mitigate the problem of having shortage of labor.
Mm-hmm. Well, quality controls is probably not the vision I was looking for. Let me pose the question differently. How far are we away from self-sufficient AI-controlled production lines?
I think
are we talking 2040?
That's a bold prediction to make, actually. So I don't really know if we're near to the realm of having fully automated production lines. But we're getting there in the advances of robotics and AI and everything. I think we can manage to have dark facilities without any light switched on and producing stuff in the future, of course.
Mm-hmm.
Okay. The limitation of AI technique is that expertise transfer, it is still remain unsolved. If so many data are available, something like tacit knowledge is necessary to good operations. So, but in essence of engineering technology or engineering discipline, we must make implicit knowledge to explicit and systematize, and then they all can use the engineering disciplines. So, in this sense, AI technology is the same. To challenge the expertise transfer is very, very essential.
Okay. How far are we away from AI organized logistics?
I mean, logistics has a lot of parts, so I would say it's definitely a more difficult thing to challenge, like all parts of logistics. I think, though, that from an information point of view, we are getting more and more there. It will be a combination of different things. It will be, we see also new legislation, increasing information, forcing also people to reveal certain information. Together with AI technology, I think we will have a much better understanding of supply chains in the upcoming years. And that will also give this opportunity to improve there and the opportunity to automate. Yeah. So let's see.
Michael, as a researcher, can I get a date from you?
Never. I would never do that. I mean, this is similar than the question to AGI. Depending who you ask, you get next day or the day afterwards. Could happen anytime soon, could happen never. So I would stick, the future is not really
uncertain.
The future is uncertain, definitely. To some degree, maybe predictable. And yes, I mean, self-optimized factories could be something of the future. But I think this idea of this completely dark factory is very, very, very far away. So what I actually expect to see for the next 20 or 30 years is basically this human AI collaboration. So where basically, for example, AI generates optimization strategies, human oversight then decides what to do. Because in the end, I mean, we also need to understand that there is that a lot of things need human creativity. And this is also something which we need to leverage in addition to using AI.
Mm-hmm. Thank you. That's a perfect last word. Thank you, Professor Terano.
Yeah,
thank you, Thomas, Stefan, Michael. Unfortunately, we weren't able to open the floor for discussions, which was, I think, thought about. But I think you guys are staying here, and the audience can take the opportunity to ask you questions afterwards when you're outside. With that said, I'll hand the stage back to Ina to guide us through the rest of the day.
Well, thank you. That was our manufacturing panel. A big applause for our panelists.